Many people who saw my post of a few weeks ago where I told a story about building an app on a 6 hour flight from London and the amount of work that I was able to get done in 6 hours were both curious and skeptical at the same time about how this was possible and whether the quality of the code that was being produced was enterprise grade. So what I want to walk you through today is something that a lot of people have asked me to illustrate, which is what is both the agentic process that I'm following and what is the agentic stack that I'm using to try and create better quality software in a more repeatable fashion, but with this incredible velocity of execution. Okay, so if you'll pardon a little PowerPoint, and you cannot take the PowerPoint out of the CEO, I apologize. Let me walk you through a little bit about how I do what I do. The first thing I think to realize is this takes a confluence of three things. Some templates that help me really get off to a very good start. A range of tools that is much more than just the agents themselves, and a core process that I follow every single time to try and improve the overall quality of the output. So let's start by taking a look at the process. Many of the apps I build, I don't necessarily know much about the subject matter. So I'll often start, often with a walk and talk, where I have a chat with one of several agents, whether it's ChatGPT or Claude or Perplexity, and together I will begin to understand a little bit more about what the problem domain is that we're going to be working on. Out of that will come a vision document, and this is very important because the vision document actually becomes a cornerstone or a touchstone for the agents over time to validate that they are delivering according to this higher level coherent view of what it is we want the app to be. Out of that vision document comes a much more precise requirements document or requirements definition document and a technical architecture. And so to go from vision document to PRD to technical architecture is a lot of back and forth with the agents, me reviewing the ideas that they have, reviewing the quality of the output, making corrections, and so on. And once that's all codified, then together we build an implementation plan, which is really a step-by-step process of how we are going to build what it is we're going to build together. And that step-by-step process is typically broken down into a series of sprints. And each of these sprints, usually because they're fairly large, is broken down into a series of phases. And here's where it gets important. For each phase, we build a kickoff prompt so we can start each phase in a new session. That kickoff prompt encapsulates what the objective of the phase is and links to any of the referencing documents that are required to help build that phase. At the end of the phase, we build a completion document which summarizes everything that's been done, lessons learned, and so on, and a handoff document that then goes to the next agent in the queue that is going to begin the next phase. And so that agent starts with a kickoff prompt in a brand new session. And that's important too, because the longer you run these sessions, the more you run into context window exhaustion, and that gets quite dangerous actually over time. So again, each phase has a kickoff prompt, a completion document, and then a handoff document to the next phase. And what's typically happening here is the kickoff prompt for phase 2 is looking back at the handoff document for phase 1, and therefore it has a coherent kind of plan of attack. Now, at the end of every phase, we go back and automatically update the implementation plan to show what has been completed. And that means that if all of this blows up and everything shuts down for 2 seconds or 5 seconds or a day and I need to come back, the agents know exactly where they left off. They can go back and understand the full architectural patterns, and they can also understand where we are along the process. Now, if you want to get really sophisticated here, you would employ something like Reuven Cohen's Claude Flow, which is an extraordinarily powerful framework that sits initially on top of Claude Code, but it really should be possible to have it run on almost anything at this point. And that provides a much deeper and more powerful set of patterns, personas for the agents, and the capability to build in swarms. That is, multiple things happening at the same time. Now, why would you build in swarms? Well, one reason is to get a lot of stuff done quickly. So let's say you want to go and document all of the directories and add a README to every directory so that, it's clear for any human or agentic coder what's in those directories. Well, you could do that in the linear process, or you could break it up and say, look, agent number one, why don't you go and deal with the, client code? Agent number two, go deal with the server code. Agent number three, go deal with the shared code. But there's another really interesting way to use swarms, and that is to kind of A/B test the outputs of the agent. So sometimes you may, have a very complicated problem that you're trying to solve, and you want three quite different ideas about how to solve it. So you'll give three different agents the same task, and then you will ask a fourth agent potentially to go and review the output of those three agents and come back with what it thinks is the best blend of how those agents have accomplished the task. So Claudeflow, Reuven Cohen, both an extraordinary person, really one of the most sophisticated agentic coders on the planet, probably at this point, and some really amazing stuff that he produces and gives away for free. Now, let's talk next about the agentic stack, because this is as important. I start every project with a canonical template. I have two that I start with. One is a React plus Express template, and the other is a React plus Python template. And these templates are fully developed, and they are always kept up to date. But when I build using GitHub code spaces. So a GitHub code space is like a virtual machine you can spin up your app in. And that saves me from having to go and spin all of this stuff up on my local machine. It's not that my local machine isn't powerful, but I'm often on a plane or in various different parts of the world, and it's not always easy for me to get back to my local hard drive. And so what I do, by having access to this virtual code space, I can basically, from any machine, including on the web, go back and continue to work on the projects regardless of where physically I am in the world and which technology I'm sitting on top of. So these canonical templates are really important in creating a very good and robust first start. But where it gets interesting is the rest of the stack. Each of these templates has integrated workflows that provide oversight over all of the code that the agents are building. Whether you are committing and pushing to a branch or whether you are committing and pushing to main, there are certain standards that the workflows enforce. So we aspire to lint-free and fully tested code that must pass all tests before the push is allowed. Sometimes we have to override that because temporarily we're just trying to get some stuff done and we'll come back and fix things later. But we try not to build kind of technical lint debt and technical test debt. The next thing that happens is the workflows will trigger secondary reviews, either CodeRabbit review for a regular branch, sometimes a cursor secondary bug kind of bot review. But from a security perspective, we also run SNCC and we run Trivy tests. So anytime anything is going to main, it is going to be validated from several different perspectives, both code and security. On top of that, we also have integrated into these templates deployment capabilities. So the templates are built from day one to deliver Docker and Kubernetes, Azure, and Railway deployment. I use Railway as my deployment platform because I find it so beautifully integrated with GitHub. But because it's built on top of Docker, I do all the work to be able to push to AKS and Azure and other sorts of things. So again, all of this is built into the templates themselves. So every time I start with one of these templates, I'm starting with all of this implicit momentum. There are also some core tools that I'm using quite a lot. So I'm beginning to move away now from using GitHub issues towards looking at Linear as my core kind of product management framework. I use Doppler for secrets management. And this is quite important when I'm building multiple apps, because sometimes I'll have client-specific instances or private cloud instances. And what Doppler gives me is this kind of wonderful hierarchical ability to inject secrets to both the code space and to Railway or Azure or whatever in order to effectively manage secrets in one place. Plus, it allows me to recycle secrets very quickly if I have to. I use Clerk for authentication. Clerk is really one of the fastest growing auth platforms now, beautifully integrated with maybe 20 or 30 different providers. But Clerk also has the ability to embed billing now into your system and organizational governance if you're doing multi-tenant. Quite a powerful system. And that's, again, all baked into the template. So I can literally just add the Clerk keys and I'm off and running. Tend to now use Neon as my sort of default relational data store. And you'll notice there's an OpenAI image there as well. The OpenAI Agent SDK is rapidly becoming kind of my preference. So on top of the core tools, then you have the frameworks. And this is where, you have to decide, are you going to be a Claude Code person? Are you going to be an OpenAI GPT Codex person? Are you going to be a Cursor person? Are you going to be a Roo person? Are you going to be an Augment Code person? Are you going to be somewhat of all? I tend now to do most of my work in Claude Code. I've become quite familiar with its quirks, and it's quite powerful, it's quite extensible, and it is evolving very, very quickly. But I'm also quickly becoming a fan of Codex. And so sometimes I will actually send the same problem to both agents and have a look at the output and see where they differ. I'll also ask one agent to review another agent's work if I'm not quite happy with it. I think Codex is extremely good at going in and analyzing large code bases and finding the problems in those code bases, whereas Claude is quite good actually at de novo code, and actually increasingly now at editing incremental changes to large code bases. Cursor, I'm actually using less and less in the IDE, and more I'm using Cursor's cloud agent capability. So that's where I can literally just fire in an idea while I'm on a walk. It'll go up to the cloud, it'll get worked on, and a PR will be ready for me by the time I get home. It's quite a powerful system, and I really am looking forward to seeing that as elegantly deployed as it is on Cursor natively into Claude Code and others. So there you go. That is a quick look at how the agents and I at Affinia Labs work together to very rapidly go from prototype to production grade software, and some of both the tools and the processes that together we have implemented over the last little while. Hope that was helpful.